Okay, today in class, one of the skills that we learned how to do today was determining the solubility equilibrium constant given the molar solubility of a substance. So the first thing that you guys need to remember is that the equilibrium constant is products over reactants. And in this case, we have these equilibriums with substances. For example, I'm going to do PB3. PO4 2, so lead 2 phosphate. Now, remember from solubility rules, phosphates are insoluble, but what we learned in class today is that that's kind of not totally true. It will, the little bit will dissolve. So we would make this into PB2 plus and PO4 3 minus. Now I knew that because phosphate I memorized, and I also knew that because this is an easy one. It switches back up. So then the last thing we need to do is we balance. So we have to have 3 of these and 2 of those. So this is my solid, and these 2 are aqueous. So we don't include the solids, but the aqueuses are included. So we're going to have a KSP that's going to be PB2 plus, and remember we raise it to the power of the coefficients, and PO4 3 minus, and we raise it to the 2. So that is the equilibrium constant for these types of, equilibriums. It's still at equilibrium because these little particles are coming together to make some of those, and those little particles are dissolving. It's not the same particles every single time. Okay? So what we do is we are given in the problem 78, that the molar solubility of the substance is 6.2 times 10 to the negative 12th moles per liter. Be careful, on number 77 it's grams per liter. So the first thing you need to do is go to moles, and then you can use it. But in this one we have easy, we're just given moles per liter. Now that's the molar solubility for PB3 PO4 2. That's the solubility for the whole thing. If we just look at the lead, we're going to have 3 times as many leads in one of these formula units of lead phosphate. That means that we'll have 3 times as many moles. So we would write this as 3 times 6.2 times 10 to the negative 12th moles per liter. Okay. And we also have 2 times as much phosphate. So we're going to have 2 times 6.2 times 10 to the negative 12th phosphate. All we do from here, those are my new concentrations. Okay. The molar solubility, in case you're confused, that's how many moles per liter can dissolve. So then, if that's how many moles per liter of the total thing, then we have 3 times as much lead and 2 times as much phosphate. We go over here to the expression that we wrote earlier, and all we do is we substitute. We will have this one, sorry I keep moving it, to the 3rd power. And we will have this one to the 2nd power. As someone mentioned in class today, the coefficients show up here from the balance equations, and then this is just 3 times as much because the subscript, they're related. But all we do here is multiply those 2 together, and when you do that, you should get an answer of chapter 15, problem 78. We should get an answer of 9.9 times 10 to the negative 55. Okay, notice how small this is. Okay, that means that this solubility this equilibrium really favors the solid. So that goes back to what we were saying in class, that it really is insoluble. Very little of it actually will go into solution. So it's pretty much negligible. Okay, so when I give you the K, when I ask for the K and I give you a molar solubility, all you do is substitute, but you have to make sure you keep track of the way that the moles are going to go for each of the particles.